Okay, folks, installment number 118. Wow, we've been around for a long time. So installment number 118 is about identifying errors in proofs. So we're not going to look at reasons why deductive proof is a flawed process. Deductive proof is perfectly fine. The problem is sometimes there are things that you can do wrong when you're attempting to construct a deductive proof. So we're going to look at things that can cause a proof to be invalid, some mistakes that folks can make, and then we're going to recognize the common errors in proofs. We're going to look at some examples of recognizing them. So the first one is what makes a proof invalid. So common error number one is you can make an invalid assumption. Remember that we said that deductive proof is about taking things that are known to be true and then drawing logical connections to reach a new conclusion. Well, if one of the things that you take for being true is actually not really true, then that'll lead you to anywhere you like, really. So that's what we call an invalid assumption, okay? The second common error that folks make is sometimes they use an invalid mathematical procedure, okay? And really the one that jumps out there that you'll see the most common, sometimes folks will try to prove something, and if you look carefully enough at their algebra, you'll see that somewhere they've done this. Division by zero, which we know is not allowed in mathematics, okay? That's prohibited. Okay, the reason is because it's undefined. So if you do something doesn't even have a definition to try and help you prove something, then you're obviously sort of skimming over that. You either made a mistake or you're cheating. Common error number three, sometimes folks will make an algebra or an arithmetic mistake in their process, okay? And that's just a very common thing. People make mistakes once in a while, so you just got to be careful to read through. And the last one is something called circular reasoning. Now, we're not going to go through an example of this when we look at our examples in a minute, but circular reasoning is very similar to the making an invalid assumption that we talked about at the beginning. Those two are closely linked. And basically what circular reasoning is, it's kind of like assuming that you think the thing you want to prove is true in the first place, and then coming up with something else that's true. That doesn't prove the thing you started with. You have to start by not knowing that the thing that you're trying to prove is true. The idea is you have to prove it from other things that you have. So circular reasoning is a common thing that people try to do, but it's not really so much of an error. It's just you're doing something backwards there, folks. Okay, question number one. Josh says he can prove that his friend Troy has a Twitter account with the following deduction. Okay, a little bit of verbal deduction here. All students have Twitter accounts. Troy is a student. Therefore, Troy has a Twitter account. What's the flaw? I bet I can see it. Right here. Do you think it's true that all students, now there's no qualification on that at all students, every student in the whole wide world, has a Twitter account? No, that's not true. And this is what we call an incorrect or an invalid assumption. Okay? So we've assumed something to be true that we know isn't true. And if that's the case, you're going to be able to prove that Santa Claus races Mickey Mouse on the weekends. Okay. Common errors. Example 2. Edwin says he has proven that 2 equals 0. See, people try to pass these off as valid proofs all the time. They say they're magic. They can prove that math doesn't work. Okay, and they always have the same error. Let's show you what it is. So Edwin claims he can prove that 2 equals 0 using the following proof. Okay, so let A equal B equal 1. Okay, so that's fine. We often will just assign variables or give them a value. That's fine. If you want to say A equals B equals 1, no problem there. So that's going to be our assumption. We're okay with that. So then if that's true, then A equals B. Well, that was given, so that's okay. Now, if A equals B, then A squared equals B squared. Yes, that's fair enough. Okay, you can square both sides of an equation. No problem. Now, if that's the case, then A squared minus B squared equals B squared minus B squared. Yes, if you want to subtract B squared from both sides, that's not a problem, so that should be okay. Then, subtraction, what are they doing here? They say B squared minus B squared equals 0. Yep, that's true. Anything subtract itself is 0, so that's perfectly okay. Then it says A minus B times A plus B equals 0. So they took A squared minus B squared, and you'll recognize from your grade 10 factoring, that's a difference of 2 squares. And that gives you A minus B times A plus B. Sure, that's fine. Then they're going to divide both sides by A minus B. Okay, dividing both sides by a minus b. Hang on now. We're going to come back to this one. And then it says we cancel out the a minus b on the left side over here, like that. And then 0 divided by anything is just 0. So then a plus b equals 0, which means 1 plus 1 equals 0, and 2 equals 0. The flaw, folks, or the error in this proof is right here. Dividing both sides by a minus b. If a and b are equal, then a minus b is what? And you cannot divide. Cannot divide by 0. It's not a defined operation at all, so you can't use that to prove something. So there's the error in that one. Cannot divide by 0. Okay, Joey says, or Jose, sorry, not Joey, says that he has proven or proved that the product of any even integer and any odd integer is an odd number. Okay, that doesn't sound right. Let's see what he did. So he said 2x is even and 2y plus 1 is odd. Okay, and then he's going to multiply them together and get this. And then he says that gives us this thing, which, since that's an integer, then it's odd. Okay, here's the mistake. Distributive property. That term is correct, but when I multiply those terms, uh-oh. So that's just an algebra mistake. Sorry, Jose. Stick to baseball. Okay, so Jose made an algebra mistake. So remember, the 4 most common errors: incorrect assumptions, invalid math procedure, and that's that division by 0, algebraic or arithmetic mistakes, and circular reasoning. You can't assume what you want to prove before it's been proven.